Good morning, afternoon and evening to our audience today. Welcome to the latest webinar hosted by Device Authority. My name is Rosa Lenders and I am pleased to welcome our key speakers for today, Rob Black, Jan Hemper and John Penny. Rob is a Senior Director of Product Management at ThingWorx, a PTC business, where he oversees the direction of the ThingWorx Foundation product portfolio. In addition to his expertise in IoT, Rob has extensive experience in security, web services, and cloud solutions. He is also a certified information systems security professional. Jan is CTO at ENVMA. He is an experienced industrial controls engineer and systems architect with 20 years experience of building process control and business systems in oil and gas, power generation, and other industrials. John is the co-founder and chief security officer at Device Authority. He is passionate about data security and plays a particularly active role in driving initiatives to protect the privacy and integrity of information traveling across ecosystems making up the Internet of Things. We expect the webinar to last approximately an hour, and you will be able to submit questions via the chat window. At the end of the webinar, we will then respond to the questions that have been submitted. Contact details are included in the final slide, so if we are unable to cover your question today, or should a question arise afterwards, please contact us. A recording of the webinar will be made available later this week on the Device Authority website. Everyone who registered will be emailed the link. I shall now hand over to Rob.
Great, thanks, Rosa. Hi, everyone. This is Rob Black. I'm here at ThingWorx, and I'm going to talk to you today a little bit about IoT platforms, our IoT platform at ThingWorx, and then some specifics about IoT security. So, one of the reasons why folks are probably on this call is because developing for IoT is complex, right? In IoT, one of the unique characteristics of the space is that you have a highly dispersed device environment. You have devices all over the place, potentially in your customer's infrastructure or their customer's infrastructure, ones with high bandwidth capabilities, one with very constrained processing power on them, and everything in between. Additionally, there have been constantly evolving platform architectures. If you looked at IoT a year ago, 6 months ago, things have been changing very, very rapidly in this space. Also, there's been a lot of kind of differences in kind of plumbing battles with different technology frameworks. Right? And you can even see that today where sometimes a project might start in-house, then it moves externally, goes to one provider, then another, and those things make a solution more and more complex. A lot of the times also when you are looking for an IoT solution, what you find is it's actually a legacy solution with the marketing material that says IoT on it. That's happened a number of times when I've been evaluating potential partners. And what happens is it requires a lot more work and understanding to be able to build something specifically for IoT. And then as we think about some of the other challenges, we think about the volume of data that's coming from those devices, the speed of which it's coming, and using that data in a timely fashion. And then oftentimes we're given a project in IoT and those requirements outweigh our current resources and development tools. So lots of things to think about in IoT. From a ThingWorx perspective, we have a IoT platform that really has a broad range of capabilities. And some of the things that you probably want to think about in your IoT solutions are the ability to connect. You want to connect to a wide variety of devices, be able to do that in a way that brings all that data up into your system. You also probably want to be able to connect to other device clouds. You don't want to be locked into one technology stack, as you may have partners or future acquisitions or some other capability where you need to be able to integrate with those systems. You want to be able to analyze that data. You want to be able to take that data and perform analysis to find out trends in the data. Can I predict if things are going to happen, if devices are going to fail, or potentially other business things that you need to analyze. You also need to be able to create. Everyone is building a different IoT solution because their business needs are different. Yes, it might look the same at the edge where you're connecting to a device, but where there's an application, you have to connect to specific business systems that may be specific to your enterprise, your customer's enterprise, and you have to give someone a user experience that's very specific to your vertical. And then finally, you want to be able to experience. You want to be able to take that data and use it in very valuable ways. Here at PTC, one of the things that we're doing is using augmented reality to supplement your interaction capability with the device to really give the user a very rich experience. And there are many use cases where you can use that to make someone's job much, much easier. And then finally, you want to be able to share both with other developers who are developing for IoT, and you want to have packaged solutions where someone solves a problem and everyone can use that. And that's what we use our marketplace for. So that's the ThingWorx set of capabilities. Now, when we look to build an IoT solution, the first thing we want to do is we want to model that solution. So we're going to give you the ability to model the solution. That's the kind of the ThingWorx secret sauce. And that model really represents the thing that's at the center of your IoT. So, that means that, let's say you have a factory, or you have a construction equipment, or medical equipment, or traffic equipment, or transportation equipment, or a dishwasher. Whatever you have, you want to be able to model that. So in the ThingWorx concept, we have this capability of a thing template that's going to give you properties, services, and events tied to that thing. Okay, so here we're modeling this thing. With properties, we will maybe want to know the number of hours that it's been running, whether it's on or off, what the average temperature has been, and is it under warranty, right? So there's all sorts of properties that we might have. On the services front, maybe we wanted to update the firmware. Maybe we want to run a diagnostic. Maybe we want to take some data and post it to Facebook. And then on the event front, we might want to know, has the wash started? Is there a malfunction? Is the door open? Any sort of thing with the washer. Okay, now that we've created a template, we're going to create a bunch of things. So we create a bunch of things. These are things that maybe rolled off our factory and now are available. And then we probably want to integrate with a bunch of enterprise systems. And this is important to understand that when you're building an IoT solution, it's not one thing. It's a big system connecting to many aspects. And as we think about some of the security implications here, it's really important to understand what's the business function that we're performing, because that's going to add to the complexity, and that's going to really point to different solutions to solve some of those problems. All right, so then, so we've modeled our thing. Then what we might want to do is we want to build an application, right? We maybe want to build an application that checks the consumables. Is there more dishwashing detergent? When was it last refilled, or what's the usage been? Do we want to do a remote update of the software on the device? Do we want to send data to the smart sign on that device? So lots of things to think about when we're building a IoT solution. All right, next thing we want to do is to connect. So we have our thing, we've modeled it, now we want to connect. There's tons of different ways to connect, many different technologies at the edge. So we build a connection. Here are some of the ways that you can connect with ThingWorx. We have a very broad portfolio for doing that, and that's because devices are all over the place. They have different capabilities, and you need to leverage those broad capabilities to be able to connect it to your IoT solution. All right, so then the next step is really we need to be able to build our solution. So we're going to build our IoT solution. We have the device connected. We have it modeled. We're going to build it in the ThingWorx world. We have a very easy way to rapidly build applications where with a visual development, you can take that model that you built and it's going to really drive your application. Okay. And so now we've built our application, but maybe given that this is a security seminar, let's think a little bit about security. What are we going to do on the security front? Now, hopefully, you didn't actually wait to step forward to think about security. Hopefully, a lot of that capability is built into your solution. But what we want to think about are different elements to help secure your solution. And when we think about IoT, there are a few challenges that are really out there. So one is, if you have a very big set of devices, how do you set the permissions and visibility for all those devices? Do you want your administrators to have access to everything inside that IoT network? Probably not. The second one is, how do you update all those devices? It's great that you put those devices out there, but what happens in year 2, year 3, year 4, year 5? Those devices are presumably there for a long time. How do you update those devices with the latest security patches? And then the next one is, what are you going to do how are you going to secure the device itself? Because a lot of the concern around IoT is access to all those devices. So we're going to talk about all 3 of those things and then even a little bit more. All right, so when you're building your IoT solution, one thing to think about is who is authorized for what. So we have 2 things on kind of on the authorization spectrum. The first is visibility, and that's where we have the little binoculars there. Right? And you can imagine that different users in your system would have different visibility. So for instance, if you were a call center agent, so all the way up to the right on the chart here, if you're a call center agent, can you see all the devices in the system? And if you're a call center agent, I would suggest probably yes, you could see all the devices in the system because you need to be able to pick up the telephone and answer a call about any of them. Now maybe you see the little check mark, that's your permissions. Maybe your permissions are scoped very narrowly. Right? Because your call center agent, you probably can just maybe see some data on those devices, but presumably you can't perform a tremendous number of activities. But now we move one step to the left here, and we see the product specialist. And the product specialist only has access to his or her devices. So you might have many different sets of devices. The product specialist is a product specialist for device 1, 2, 3, 4. Can only see devices of that model type. However, that product specialist has a lot of permissions to be able to fix things inside the scope of his or her product. And you can see here where we have different use cases of regional manager, or service technician, service manager, or system administrator, where different folks are going to have different levels of visibility and permissions. You want to be able to model that. And this is really a IoT unique problem. So, one of the things that we have done in ThingWorx, and you want to think about this in any IoT implementation, is, what are you going to do from a permissioning scheme? And with ThingWorx, what we've done is we've really given very granular permissions for each and every element of the solution. And that way, you could have certain elements that are visible or have permissions for certain sets of users, and you have other elements where, so maybe like if you want to update a property, for instance, that can only be done for certain specialists. Okay, so it's very flexible. We have both runtime and design time permissions. We have it from the thing and all the way down to individual elements on the thing itself. That's a capital T thing. Okay, and then the next piece is, okay, so that was on the permission side. Now on the visibility side, what devices can you see? So what we do is use the concept of organization to drive visibility within the system. Can I see that device? Can I see that property on that device? And using that information coupled with the permissions gives the user experience with visibility and permissions. So this is a simple solution to a complex problem, and one that you should think about if you're doing an IoT implementation is how are you going to manage permissions? Because this is probably going to be, as soon as you actually start to implement, this is probably going to be one of the things foremost on your mind from a security standpoint. All right, so the next one is software and content management. And when you think about devices in your industry, how long are they out inside their deployment area? Are they there for, for years? How many years? 5 years, 10 years? Because when we look at a lot of the devices that we help to support, those devices are out there for a long, long period of time. And those devices oftentimes are not in your enterprise. They're in your customer's enterprise, your partner's enterprise, someone else's network, right? And so what that means is for you to be able to update that, you need a very deliberate scheme to be able to do that update, right? So you want a scheme that is scalable. You want to be able to create a package and basically specify all the things that you might need. Here are the files, here are the install instructions, here are the rollback instructions. You want to be able to do a deployment because just because you've created a package for all of the things in your environment doesn't mean that you can deploy them, right? The deployment might be you need to get customer permission before you can do that update. or maybe you don't want to overwhelm a customer's network, so you have to scale back that deployment. So those are things to really think about. Then you also, of course, want to check eligibility, right? And so basically, so from both a package standpoint, you don't want to push this package to every single device in the network. You only want to push it to ones with certain sets of characteristics. And so you need a very flexible solution for software and content management. Today, when you think about solving this problem, oftentimes it's in the realm of IT, right? So you have a Windows update capability where you can push content to all the Windows machines in your enterprise. But that does not mean that, for IoT, that's not going to really work, right? You have machines out there that are Linux machines or some crazy OS variant that no one's ever heard of. So you need a solution that can diversely connect to all those devices in your enterprise, can handle existing business and also future business with new operating systems, new protocols, and new capabilities. All right, so now finally, we're talking about concern about being able to touch the device. This is probably one of the biggest things that folks get concerned about. Oh, I can't do IoT. My device is going to be exposed to the internet. That means that all sorts of bad guys could touch it. They could get my data, or they could interact with it, causing bad behavior on that device. So the way we solve that problem at ThingWorx is with device-initiated communication. And so device-initiated communication means the device knows who its parent server is. And the device is the one that says, hey, parent, I'm here. Do you have any messages for me? And so with that, or basically it sets up the connection itself. So what that means is that device is not eligible to transmit with millions of servers around the world. It's eligible to transmit with a single one. And so what you're doing is you're really limiting the attack surface from the whole world to only the authorized server, which of course is either safely in your infrastructure or your IoT provider's infrastructure, right? And there are all sorts of great cloud controls that you have to, cloud security controls to help prevent any sort of security problem. The other nice part is from a firewall standpoint, and so this is something to think about, when you're deploying a device inside someone else's environment, what is the worst thing in the world? Oh, could you punch a hole in your firewall for IP address, XYZ? And what that means is that every time there's a change, you're going to need to talk to their IT provider to add new firewall rules. Well, guess what? If it's device-initiated communication, the device is initiating the communication out, and so you do not need to adjust their firewall. So this is a really powerful concept. One of the reasons why ThingWorx is, people like to use ThingWorx from a security perspective because it helps to alleviate a lot of those problems. Okay. All right, so now, so I talked about some of the great characteristics of ThingWorx, and what ThingWorx lets you do is it lets you build a very broad IoT solution. So it's inherently a development tool that's going to let you build at the edge. In the cloud side, it's going to let you build your applications. It's going to let you build integrations to other systems, right? And those systems could be, business enterprise systems like your Oracle or SAP system, right? It could be to a big data analytics package, right? Maybe you're taking data in or sending data out to some other sort of cloud services. And you could also be running applications either, by you or a system integrator on your behalf, or maybe you're buying an app from a partner, or maybe you're buying an app from PTC, right? So there are all sorts of different ways that you can buy apps or integrate with other systems, and you can utilize the very flexible framework of the ThingWorx solution. Now, one of the things to think about from a security situation when you're building such a solution, and the reason that we're here on this webinar, one of the reasons, is to think about, now I have all this data that's sitting at the edge, right? So this data is at the edge, it's coming from different devices, and it's going to be available. And we're going to take this data, and we're going to distribute it not just into our IoT system, but to these apps, and to these other systems, and to these cloud services, right? And so now when you think about, okay, so I have all this data and it's going to all these different places and there's, different sets of data. What am I going to do in terms of handling, some of the security capabilities around specifically that data? And that's why, companies like ThingWorx like to partner with companies like Device Authority to help solve some of those problems. And so, now I'm going to turn it over to Jan, and he's going to take you through the rest of the story. Jan.
Hi, thanks very much for that. If we can just get the slides up. There we go. Hello everybody, I'm going to say hello because I'm not sure where you all are. I don't know what time of the day it is. My name is Jan Hemper. I'm in the UK at the moment, and it's the afternoon. So what I'm going to do is I'm actually going to present some information around a real world use case. So it's not a hypothetical use case. This is one of our customers. It's actually based on a connected medical device. And I expect that you'll see some of the parallel challenges that we're going to see in this in all manner of the types of IoT applications that you guys are working with. And I hope that you can relate this particular customer scenario to your business. We're hearing a lot about security recently. The beginning of this year, January 2016, the US Drug and Administration, or Food and Drug Administration, actually issued guidance specifically relating to medical device manufacturers and the steps that they should address to look at cybersecurity. Only earlier this month, the European Union have brought in new regulations around the protection of personal data and what needs to be done for that. So I'll go through this. The way I plan to do it is I'm going to explain first a little bit about the opportunity and what our customers trying to do, then around the reasons that this is challenging and how we look to overcome those challenges. So our client is an OEM provider of medical devices. These devices are used by vulnerable patients, both in their home and the portable devices, so they can use them on the move. Just a little bit about the devices. The products were initially unconnected, so this was a standalone piece of kit, but these devices require servicing. They have consumable parts that must be replaced. They also require regular visits from clinicians to make sure that they're working correctly. In terms of the business model, these devices are normally sold by our client, the OEM manufacturer, to a number of different healthcare providers, and generally those healthcare providers are responsible for prescribing the use of this type of device and also dispatching the logistics of delivering that device, training the patient on how to use that device, and servicing the device and replacing the consumables. They're also in many cases responsible for the clinical care of the patient in respect of their condition and how the device is helping them to improve their condition. So in the traditional, or in their original traditional business model, these devices were isolated, and because they require regular service visits to validate the operation and replace these consumables, they were seeing increased or time-based service visits to patients' homes when things could clearly be done more proactively. Further to that, healthcare professionals were being required to visit the home of patients with relatively high frequency, perform tests on patients, look at the prescription element of the device and make adjustments there. And also, these devices being fairly costly were not being retrieved in a timely manner when they were no longer required or no longer used. So in the traditional approach, that's some of the challenges that they had. Looking at this new connected product strategy that we're implementing now, they've got a number of benefits from that, in that there's a differentiated service offering between their competitors, and it allows these healthcare service providers that buy the devices to be much more proactive in the service approach, which significantly reduces service calls whilst reducing failures, and also improves first-time fix rates when things don't go correctly. As I mentioned, these devices have got consumables, so there's the added benefit of automated consumable replenishment there. You know, they're not going to be checked for when the consumables need to be replaced. That can be automated. There's, very importantly, the enhanced clinical information that's available to healthcare professionals to allow them to remotely make judgments about the improvement or deterioration of a patient's condition and intervene as necessary. So a reduction in the number of healthcare visits required. And then for the OEM themselves, there's a number of benefits around actually feeding information about the in-field device usage back into the R&D cycle to help them to improve product design and continually enhance and evolve the product. That's also true for one of the other benefits, which is over-the-air firmware updates that allows them to remote or implement product enhancements remotely. If we could go to the next slide, please. Thank you. So in this particular system, when you consider any IoT application, there's an expectation that the roles will be quite varied and span multiple organisations and in many cases multiple systems, and that is where quite a few of these challenges are presented around security. So in this particular application, we've got the patient themselves, the VIP right at the bottom there. Clearly, the patient's really only interested in their interaction with their own medical device. That, you know, they don't care about the R&D statistics or what people do with their device. They're in the middle. We've then got service providers, and I mentioned that multiple healthcare providers buy these. There are multiple healthcare providers who've got multiple personnel doing different roles, so they quite often have clinical staff, they quite often have mobile technicians, they quite often have engineers that go around and fix these things. And their personnel should only be able to see information that's relative to their job, and clearly one healthcare provider should not be able to look at another healthcare provider's performance in that way. Clinicians, probably one of the most important ones, they're really the only ones in this application who should have access to real personal and privileged information with regard to patient records and previous health conditions. And also in many cases, to get to the patient, they will use precise location information about that device. We've then got other people, mobile technicians running around in vans, delivering devices, fixing devices. They're really interested in diagnostics information, alarm logs, fault logs, that type of information. They should never be in a position where they can view privileged information about a person or their medical history, and also shouldn't be able to view the R&D information that the manufacturer can. We've then got finally the OEM engineer. All they're really interested in is enhancing the product, looking at feature usage, improving problems with the product and enhancing it. Again, in this scenario, we've got multiple systems that are connected. So we've got patient record systems, we've got the OEM's ERP system, healthcare provider logistics systems for multiple healthcare providers, and also other tertiary things such as technician ticketing systems and logistics tracking systems for the location of vans and things. Okay, if we could go to the next slide, please. So really what I've done here is just try to give a very basic view of certain features. We've pretty much talked that over. So the patient's interested in the device performance, which directly relates to their health, their own information and the location of it, should they misplace it. They're not really bothered about battery performance. That's something that's a manufacturer's issue. Clinician, similar thing. They again can look at the patient's information, their performance, perhaps some medical systems, how the device is performing, but again, not really interested in battery performance. Then you've got the technician, totally different role. He, under no circumstances, should be able to identify the patient or look at their personal information, but does need to know about, device performance, battery performance, those sort of faults. Okay, and if we can move on from there. So really the challenges that this presents are multifaceted. We've got the patient records and confidentiality. Cybercrime is causing a huge threat, and at the moment there are really three types of people who use cybercrime. It's the people who use it to make money by either selling data or blackmailing companies for its return, people in it for the fame, or people who are doing it for political reasons, should we say. These sort of security breaches, revealing patient records, really do destroy patient confidence, cause massive brand damage, and you risk potential prosecution and fines. Incidentally, there was actually a report by, done in collaboration with BAE, a division of BAE Systems, that indicates that cybercrime is costing the UK economy around 27 billion. And that report actually found that the pharmaceutical and biotech sectors are being hardest hit. 9.2 billion of that being lost to intellectual property theft, about 7 billion to industrial espionage, and 2.2 billion lost to extortion. Another challenge which people are quite often not aware of is counterfeiting of consumable components. And for a long time now, particularly in the medical industry, a lack of hardware-based encryption has been causing widespread concern about people using counterfeit, lower-cost parts. This problem is particularly prevalent in the use of battery-backed-up devices. So there have been a number of instances of battery counterfeiting where the ready availability of grey market untested copycat type batteries is with inferior components many people believe are putting life critical devices or compromising them and leaving them susceptible to malfunction or not as they should. Electronic prescription delivery, clearly that is a matter of huge concern, both from the side that it should be impossible to hack a device and actually purposely apply an incorrect prescription to that for the purposes of fun or for fame or some of those reasons we mentioned earlier, but also in terms of system administration problems. Maybe someone accidentally sent the wrong device or the wrong prescription to the wrong device by making some error in the system, and clearly when you're talking about people's lives, that needs to be protected against as well. So there are additional elements of security that we need to bring in to look at these. But I'm glad to say that the experts have said that so far no one has died as a result of hacking, but the risks are growing. So hopefully now we can move on to John to talk about how that can be implemented. And just to close out, I just wanted to say that I'd hope you guys would take away from this that these types of challenges are relevant in almost all IoT applications to a greater or lesser extent, and more as this legislation increases around this area, the damage that can be caused by these type of breaches, particularly access to personal and privileged information, are no longer limited to brand damage. There are certain consequential penalties that people are now regulating for are increasingly significant. So turn over to John to explain a bit about what we can do about this.
Fantastic. Thank you very much, Jan. It's great to get some insight into an actual customer deployment of some connected technology, particularly in healthcare. So my name is John Penny. I'm the CSO of Device Authority, and over the next 10-15 minutes, really I want to give you a quick overview of the solutions within the Device Authority portfolio, and particularly how they relate in this instance to protecting data within a connected healthcare environment, but also how we elevate particularly the standard security provisions that already exist within platforms like ThingWorx, and really elevate that security posture for our customers and make it simple for them to add, for example, a more data-centric approach to protecting their data assets. And then finally, we'll be demonstrating our approach to this problem in a real live demo of a connected medical device that we're going to be protecting data for, and showing you some mashups or visualizations of that data by different user types. And we've already seen how there are some very specific requirements, particularly in the connected healthcare sector or market, for different roles within the kind of supply chain, the data supply chain for users to access different types of data. And we'll show you how we're going to use our technologies to help do that more securely. So by means of an introduction, firstly, Device Authority is simplifying security in the Internet of Things. And we're doing that fundamentally, and this is really at the core of all of the technology we deliver within our stack, this strong trust anchor, which is bound to the hardware of the devices themselves to provide identity for things within the ecosystem. We're using those same identities or those keys and certificates that we're generating dynamically. I'll talk about those a bit more in a moment, to provide data-centric encryption services for the data flows that move across the networks, whether they be trusted or untrusted. In fact, if you're using device authority technology, we don't actually care, because we're providing protection for the data assets end-to-end at source and right away up to final consumption by the application, which we're actually going to show you in the demo. All of this is driven through business policies, so no complex scripting for anyone to do here. This is all policy driven to ensure that we drive compliance, integrity and trust. And areas that we're innovating in with our customers are in areas such as service access control, which is really about the authentication and access control, not just of devices, but also to services further up the stack on those devices, such as APIs and applications. Data asset protection, which is really about protecting the data itself. Secure over-the-air and over-the-network updates, which we've already talked about in Rob's presentation, particularly for updating critical things like firmware within highly distributed Internet of Things networks. Revenue stream protection to protect against the forgery of actual physical devices themselves. We've already heard mention of that within the healthcare sector there from Jan. And also how we assist in the management and provisioning and onboarding of traditional certificates within these environments. So, why is this particularly problematic within IoT? Well, I think within IoT what we see is a massively expanded attack surface, and that's really because of the complexity, not just because of the scale and the number of devices, which obviously is a key consideration and is probably the main thing that people talk about when they reference the IoT and the challenges of security. But I think the complexity of the data journey really is quite important, if not as important as well. Because really we have, some of the following considerations to bear in mind, and that's that infrastructure as a service and platform as a service is pretty fundamental to building out an economical IoT infrastructure. These aren't things that you can build end-to-end from scratch yourself. We have to rely on third parties to provide these, and those represent untrusted off-ramps into networks that perhaps we can't persist, for example, transport-based security across. Public networks clearly form a critical part of this. You're not going to be able to build your own private network to support the end-to-end communication. So public networks are critical, again, potential off-ramps into untrusted zones. We have connected supply chains that are becoming ever more complex, and within IoT that's certainly never been more real. And I think most interesting, the emergence of fog computing as a paradigm is really distilling all the valuable data. So at the edge we're doing a large part of the job for the bad guys by taking all of the data and just extracting all the valuable stuff that needs to be sent back to the central hub for processing. So that attack surface becomes even more relevant where we have fog computing paradigms in play. And this terrible lack of standards, it's really quite a dire state of affairs, particularly at a hardware level. It really is driving complacency, because frankly putting this together in a secure fashion is really just too hard. So I've mentioned it a couple of times, multiple off-ramps into untrusted networks. So no presentation would be complete without an analyst slide, and I think Gartner have come out with some interesting predictions in a recent report called Gartner Predicts 2016 Security for the Internet of Things. And 3 points really I think of interest to us in this webinar. Firstly, that by 2018, over half of IoT device manufacturers will remain unable to address product threats from inherent weak authentication practices. So it's clear from that prediction that there's concern that standard approaches to securing devices from an authentication perspective simply aren't good enough. I think more seriously, by 2020, they are forecasting that over a quarter of all attacks in the enterprise, and just think about the scale that exists there in terms of breaches today, will involve IoT. And unfortunately, we have a prediction attached to that says that IoT will account for less than 10% of IT security budget. So clearly, we've got somewhat of a misalignment there that maybe we all need to think about. But interestingly for us, and in terms of device authority and the business that we're in terms of securing these ecosystems, over half of the expenditure within IoT security is going to be around discovery, provisioning, authentication, data protection, which is really at the core of what we do. So, IoT breaches, IoT may be a new phenomenon, although, obviously, actually M2M and industrial control systems and SCADA, etc., have been around for a while. Well, in fact, so have IoT breaches. And, looking back just fairly briefly over the last 10 years, we've had, several instances of breaches that have been actually pretty high profile, but perhaps we forget that these are actually, in essence, IoT-related breaches, given that they are a breach of critical control systems. Stuxnet, really, it all started with in 2007. We've had reports of over 159 successful cyber intrusions over 4 years, including 59 pretty significant root compromises at US nuclear facilities. We've had reports of smart grid breaches, one relating particularly to a Tritium building management software breach that involved in hackers, or resulted in hackers taking over control of an industrial heating system. We've had the now famous avionics breach by Chris Roberts, 15 to 20 times through the in-flight entertainment systems of airplanes. An oil rig breach off the coast of Africa, 19 days to get that operational again. If you consider that 90% of global shipping is via the sea, that has some fairly serious implications if we think about that in a broader sense. And then more recently, as some of you may have read about this, the very substantial attack, successful attack on the Ukrainian power grid, which was really the first hack to take down the entire power grid. And that was using something as simple as an exposed VPN credential to gain access to the direct access to the SCADA network. I think that was over 60 substations taken down and about 250,000 customers without power for a number of days. I've put the links to the different articles there if anyone's interested in reading up more on those. So I think also interestingly, if we look at our industry, particularly in terms of IoT and smart connected devices, actually security maturity doesn't necessarily equal immunity. So if we take the example of Tesla, who are very much considered to be probably half a decade ahead of the rest of the industry, particularly from a security posture perspective, even they can get it wrong. And this was very well illustrated and dramatically illustrated at DEF CON 23 back in December 2015, where, albeit it was a physical teardown of a Tesla Model S, they did manage to get to a set of VPN keys held in clear text in an unprotected area of the car subsystem in a file called carkeys.pen, and that really was the keys to the kingdom. Now, fortunately, Tesla were in a situation to be able to patch that pretty much overnight, so they didn't have an expensive recall, but unfortunately the rest of the industry isn't in that same enviable position. I think you need to look at Chrysler and the Jeep hack that's pretty prevalent in most IoT security presentations these days. They've kind of become a byword in that sense. It's clearly still have some challenges here. So, I think if we look at, maybe why we're getting it so wrong, well, I think, there are a number of challenges and issues with existing underpinnings to security that really form the foundation of how we're expected to secure this very complex end-to-end ecosystem at such large scale. So, if we look at 6.4 billion connected devices this year, moving to 50 billion potentially according to Cisco by 2020, I think we have some serious challenges ahead of ourselves, indeed even today. And from an existing technology underpinnings perspective in security, I think these four things are fairly key. From the bottom up, I think take the fact that traditional certificates don't actually identify devices. At best, they're a loosely coupled relationship. I mean, at the end of the day, you provision a CA-generated certificate onto a device, and that's what basically makes that association. Those certificates themselves are an attack vector. We've got plenty of examples of breaches that we can point to. Historically, traditional PKI is very hard to scale and costly to manage. Certainly that's been the case historically in enterprises, more so at scale. And existing transport security doesn't provide protection end-to-end. So in terms of device authority, we have this strong device-bound trust anchor that is connected inextricably to the DNA of the IoT hardware itself, so it's a properly connected relationship. We have dynamic certificates because of that allow us to create one-time use keys that we can cycle very aggressively, so we don't have long lifetime certificates sitting on devices vulnerable to attack. We have dynamic keys that we can use to eliminate PKI and deliver IoT scale, or we can use the same key architecture and dynamic certificates to actually securely provision traditional certificates. And our data-centric encryption using those same keys and certificates allows us to do end-to-end payload encryption. So in terms of IoT and how we think about the development of applications and security, I think really we have this paradigm where we talk about IoT enablement rather than IoT development. And traditionally, it's very much been about application development, which has a long time frame in terms of development time and high cost. Now, making that a secure application for IoT adds many more months and if not years to that process. And within an IoT sense, where we have time to value as the IoT necessity, that's no longer acceptable. And we have to be talking about IoT application enablement. And that's really what ThingWorx brings to the equation in terms of their application enablement platform. And to help make that more secure, Device Authority have created a specific extension for ThingWorx to allow application developers to just add and enable a security stack within the ThingWorx platform. And we're ThingWorx ready and actually in the ThingWorx marketplace ready to go. So moving on to our use case demo, we're going to have a live demo of this in a moment. I just wanted to quickly take you through the end-to-end process so you understood what we're looking at. Far left-hand side, top left-hand corner, we have our connected medical device. That's creating some data sets that has some information pertaining to the patient and the critical health data, such in this case as oxygen saturation levels. And then we also have some additional data relating to the health of the device. Now, we have simplified this in a simulation, in fact, but we've taken some health data relating to the device itself, such as battery life and the device status, which is either, in our instance, actually healthy or unhealthy, but it's a simplified example. What we're going to be doing is using policies on our Device Authority agent, encrypting that payload, but we're going to be doing that using policies that allow us to encrypt the payload to two different keys. One set of keys that belongs to downstream clinicians for the doctors to be able to view the patient-specific data, and another set of keys that allows the technicians who are responsible for the upkeep of the actual healthcare device to view only the salient information relating to the health of that device itself. So the location data possibly for the engineer call-out, the battery life, the device ID, and the device status in this case. But what we're also going to show you is how we secure that data and persist that security throughout the end-to-end lifetime of the data. So from the data itself into the off-ramp of the untrusted network, through the MQTT broker in this case, and then ultimately landing in the ThingWorx platform, where our Device Authority security extension is only going to decrypt the data as and when we bring it up or render it into the view that the users are authorized to view. Whilst the data is stored in ThingWorx, it's still going to be encrypted. So I'm going to show you that now in a real-life scenario. I'm going to switch to the demo. So we're just going to kick off our script. This is actually our data creation script, so we don't actually have a connected device here. We're actually simulating the data payload coming out of a device. And this is actually a payload that's been encrypted. It's already passed through our agent. So what you're seeing here, you can see the individual JSON element identifiers such as device status and battery life, but the ciphertext, as you can see, is the only data that you can read here. We're going to switch across now to the intermediate MQTT broker. Now, if you had a transport level security solution here, you would see clear text within this broker if you're able to get into these message queues. Not in the case of Device Authority because we've persisted the security around the data itself. So you see ciphertext and ciphertext alone. If we skip to the next slide, which is going to be, the next view, which is going to be the actual ThingWorx view itself, we're actually viewing the data content within the ThingWorx platform sitting in the database. So this is before we start to look at the mashups or the visualizations of this data once the users log into it, i.e. the clinicians and the technician. As you can see, that data is still encrypted. So we're going to switch to our first mashup view, which is our clinician login. Now, don't be confused by the fact that we have our technician data on this mashup as well as the clinician view on this mashup. We wanted to put both views on one so you can see that actually it's the same set of data, but in fact our policy controls within the decryption component of our extension is determining what data can get decrypted and rendered up into this view. So if we toggle this button here, actually what we're showing you is the underlying ciphertext that sits in the database that you'd already looked at in the previous slide. But alongside that, in the case of the clinician, because that's who we're logged in as currently, you can actually see that we've dynamically decrypted that data, and we're actually showing you the patient ID, the patient name, and the current oxygen saturation levels, as well as the geolocation of that particular patient. If we switch to the technician view, you can see that our dynamic policies have masked all of the patient-sensitive data that would normally be regulated, for example, only viewable by the clinician, and the only data that's available, in fact, is the device ID, the geographic location, and the status information that the technician would be interested in order to maintain that device. So that concludes my part of the presentation and the demonstration. Thank you for sitting through that and listening. I think we may go over to questions now for the last 5 minutes or so.
Yes, thank you, Rob, Jan, and John. I've been monitoring the questions that have been raised via the chat window, so I'm just going to go through a couple of them now. So this one I think is kind of for Rob and John. So apart from device-initiated communication, what other security practices do your partners recommend?
Yeah, sure. So, so this is Rob. Good question. Yeah. So, you know, in this webinar format, of course, we can only talk about so many features in the product. From a device standpoint, obviously there are lots of things you want to do to lock down that device. So, you know, so I think, you know, first from a device standpoint, you want to think about, you know, what are the interfaces that expose the device in general, and independent of IoT, just independent of IoT, you know, how can that device be compromised, right? Is it on a network? You know, what ports physically are there? What ports are exposed through the network? And then, you know, what software services are on that device? And, you know, my recommendation for all those is to lock down all the things that are not absolutely essential. Then, additionally, thinking on the device is it up to date? You know, what environment is it used on, and, you know, can you do a threat assessment for that use case? So I think a lot of the times on the device side, it's highly tied to the operating environment. So for instance, the kind of procedures you'd put in place for, you know, let's say a piece of medical equipment in a hospital would be very different than, you know, a consumer piece of equipment in a home. You know, presumably but the thing is, you need to really kind of do that analysis and understand yourself. Also keep in mind that most of the threats on that device are probably not specifically tied to the IoT software. You know, and then additionally, if you want to go outside the device, you know, what tools do you have for monitoring? Are you monitoring the logs? Do you have network monitoring? Are you auditing the users that are authorized on that device? So kind of general good security practices. I don't know, John, if you want to jump in on any other items.
Yeah, yeah. Thanks for the question. I think, you know, Rob's absolutely right. I think you've got, you know, some fairly sort of fundamental, basic kind of security hygiene stuff. That's certainly around user security, you know, network security is you know, kind of pretty critical, and you know, I think a lot of that stuff is generally available, you know, out of the box in a lot of solutions. You know, the risk assessment point I think that Rob makes there is quite a valid one. You know, there'll be levels of security that are appropriate for, you know, certain use cases that aren't appropriate for other use cases, and I mean, I think healthcare, particularly in what we've outlined to everybody here today, is, you know, probably one of the most extreme in terms of, you know, there are real lives at risk. It's a, you know, obviously a heavily regulated industry. So, you know, beyond the basic kind of hygiene measures, I think, you know, you really do have to look at, you know, that strong kind of level of irrefutable authentication of services. You need to look at, you know, building that strong kind of trust anchor that allows you to build that strong authentication service. And actually, fundamentally, you need to look at the data. At the end of the day, you know, the stuff that the bad guys are after really is the data, and if you you know, distill it all down, then really that's where, you know, the majority of your focus should be in terms of, you know, deploying assets to protect yourselves is really around the data, and you know, hopefully we've demonstrated some of the measures within device authority that we make available to our customers within the ThingWorx platform to do that.
Thanks, John. I've just had another question just to confirm that all the data is real time.
In the demo, I guess, yeah. So I think in the demo, yeah, it is real-time data. It is simulated. I mean, as I mentioned, I think at the beginning of the demo, we did whiz through it quite quickly, and I apologise for that. I wanted to leave time for questions, but we are simulating the data source. So the script that you saw us kick off in the first screen is actually generating real live data, and we were processing that live through our agent. So yes, it was real-time.
Okay, one more question. Is this TPM plus X509, what makes the certs dynamic, and how does the process around that work?
Okay, a few questions in one. Yeah, so in terms of TPM, I mean, certainly our technology has the ability to take advantage of secure elements and hardware-based security components like TPM and TEE. In terms of the dynamic keys, we didn't have too much time to go into the detail on that, but effectively what we're doing is we're actually using entropy from the devices themselves. So if you imagine our standard agent code base being deployed to either devices on the manufacturing line or out to existing deployments of devices, which is very straightforward to do because it's a simple code footprint that we need to deploy that has no variable elements in it. There's no variable certificates in there. Once that's deployed, we have the ability to dynamically create effectively industry standard keys and certificates to facilitate both our authentication processes and our encryption processes. In fact, they're symmetric keys. In fact, not asymmetric keys, maybe like X509 that I think you referenced in the question. But there's a lot more detail we can go into, certainly on the dynamic key capability, and we'd love to cover that off with the gentleman or lady that asked the question. But certainly get in touch afterwards, and we'll do that.
Okay, just one final question. I think this was aimed during your presentation, Rob. Will device authority be available on the soon-to-be-released ThingX, ThingBrowser, ThingServer?
So, so today Device Authority has an integration built with ThingWorx, and that capability today you can go to the marketplace to get that. In terms of other solutions, so the ThingX solution is actually built on top of ThingWorx. So in terms of securing the data through ThingWorx, that absolutely would work very similarly. On the ThingX, if that's something that you're interested in, we can absolutely explore expanding that integration and helping to solve that use case as well.
Okay, thanks, Rob. Any questions we have not been able to answer, we will be answering individually this week. We've now come to the end of the webinar. A big thank you to our speakers, Rob, Jan, and John. I'd just like to remind you that our next webinar will be on the 2nd of June. We will be joined by Brian Whitten, Symantec's Senior Director of IoT. I'd like to thank everyone for their time and interest, and we look forward to speaking to you further in the near future.